Hello, YouTube viewers. Welcome to my show, Rocket Monday. In today's episode, we're gonna talk about Boeing CST-100, aka Starliner. So let's dive right into it. Well, first we have to understand about what the hell we are talking about, what the heck it is. It is a very simple, think of it this way, that there is one new player into the bid known as Commercial Crew Program or CCP basically. Now, NASA started this program after Space Shuttle was retired prematurely. So you have to understand this. Space Shuttle was there, it was working, everything was fine. Again, except the part that it was very deadly and killed 14 astronauts. NASA already had something in mind what they're gonna do in the future, basically a next generation thing. So they had something in mind and ready, but it was prematurely retired because once finally people realized it's failed to deliver on even a single thing. Basically, it has like okay, 10 things I'm gonna do. They failed on all those 10 things, so people had to retire it. Basically, it was becoming too costly. So in those sort of scenario, NASA was left in a position where they became the first country to went from okay, I had the ability to send astronauts to the space, now I have lost that ability. Basically, to give you context, China has the ability to send astronauts to space, Russia has the ability to send astronauts to space. All of them still retain this ability. America became the first country to lose this ability. So it became a very serious what you call security risk and basically an insult to the face. So the whole target of CCP, a commercial resupply commercial crew program, is basically send American astronaut from American soil. That American soil is the important because again American astronauts are going into space using Russian system, using Russia's launch pad. So they want to remove that because Russia is charging whatever they want to charge it because you have to pay for it. So and this system was designed in such a way that they will not have one point of failure. So there are three people doing same thing at the all time. Basically, NASA is using Orion, SpaceX, which is using Dragon, and Boeing, which is using Starliner. Basically this video. So that's what's happening here. Basically, space shuttle was prematurely retired, so there was a vacuum. To make sure that never happens again, NASA is like, okay, instead of NASA doing everything, NASA will have multiple partners trying to do their best. So they originally wanted to have like at least 4 or 5 partners, but only two came through, which is SpaceX and Boeing. And they will have NASA, which will be making Orion. SpaceX will be having Dragon and all this. So they will have, at worst case scenario, they will have at least one person, like one launch ability of an astronaut system. So that is what we are talking about here. So what is Starliner? Starliner is basically commercial space transport. Commercial, I'm saying, crew space transport, CST, and 100 is just randomly put there because that's quote unquote Karman line, quote unquote space line. So yeah, that's what it is. Now the whole idea with CST-100 or Starliner is very unique. It's basically this is one of the system that can be launched from multiple systems. So you have to think of this way. While all the thing Boeing is making is just making the capsule, they are not making the rocket. So they wanted to design in such a way they have multiple layers of redundancy, aka they can launch from multiple systems. Because if let's say you put it on Atlas time, something happened on the launch, rocket blows up. So the crew ejection system will work. They will take out the astronauts. Astronauts will be safe. The capsule will be safe. Everything is okay. Here's the deal: the rocket would be grounded for extended period of time, sometime as long as 1.5 years. So in those sort of scenarios, you are stuck. To make sure that never happens, it has multiple systems. So let's say Atlas 5 blows up, they can ditch to Atlas 4. Atlas 4 blows up, they go to Falcon 9. If Falcon 9 blows up, they can jump to Vulcan. Again, Vulcan is still under construction. So you get the idea. They have multiple systems. So in event of a rocket failure, they can easily ditch to second system. Easily, like done. Basically, they will. This gives them extra layers of redundancy. This is also the another reason why NASA is paying Boeing over the budget, basically. So Boeing was like, okay, this much budget. NASA is like, yeah, we gave you. You failed to deliver. They're like, again, we have to give you because NASA wants to make sure they never are in a position where they have like okay, only one player. They want to have multiple player. That is why like SpaceX and NASA itself is not enough. They want to have multiple system. So they want to have NASA, SpaceX, and Boeing. So that's the whole reality. Now, max crew capability is 7. Now, you may think 7 is huge. That's space shuttle. Well, that is true, but you have to understand space shuttle was 2 in 1. Basically, it was cargo launcher plus crew launcher. That is why it was so freaking huge. Basically, it could put whole Hubble Space Telescope into its cargo bay and basically International Space Station modules in itself. So it was very huge, overbuilt, ludicrously expensive per launch. So this time they are like, okay, let's simplify those things. You're just gonna have to take the crew up. We're gonna have a different rocket, let's say Falcon Heavy rocket, just to send the cargo up. So They've simplified it. So 7 is the maximum capacity. However, it will be limited to 4 to ISS, which is one more than Russian system. And the reason for that is basically they want to have rooms for the experiments. Basically, 3 crews that they are saving, they can have like that for extra refrigerated cargoes and things that have to go to space and have to come back, not burn up in re-entry. So that room is very precious. On top of that, now this is very interesting part, is they want to have the ability to land on land instead of ocean landing. They want to have land landing. Why the heck they want to do that? Russia does this. They have been doing this for a very long time now. The reason for that is basically Dragon capsule, when it re-enters, it suffers a serious damages. Like, okay, it hits up, it has a lot of G-shock, it has like, it withstands something. Now is designed to handle that. It gets like, I got this, bro. Now the moment you hit it on the seawater, seawater is like the physical shock. Capsule is like, I got this. Corrosive nature of seawater is like, I can't do anything about it. Like, it corrodes the hell out of it. So to make sure, and you have to understand, they do not have the luxury of making it thick. How ship hulls are ludicrously thick. They do not have that luxury. It's a space vehicle. So it ludicrously increases their basically cost of recovering the craft. Basically, they got the craft, they have to recover it, and they have to repair the whole damn thing. So to make sure they don't have to repair the whole damn thing, they are using the landing approach. However, the system is designed, tested, verified. In case of a Abort system, they could land on sea and the system will be safe for that. However, the recovery procedure will become more expensive. So that's the whole goal of Starliner. Why they are going to capsule design rather than some new BFR kind of concept and all that jazz? Well, first you have to understand the size aspect of it. You take Apollo system, which was designed to take 3. This is bigger than that, obviously, because it is designed to take care of 7 people. So it's bigger than. However, it's a bit smaller than Orion system. The reason for that is kind of unclear, because Orion was designed with SLS in the mind, so it has a higher diameter, larger diameter, quote unquote. So if you have to understand the size, think of this way: right exactly between Orion and Apollo, exactly in between. So the reason for this quote unquote capsule design, basically it's time tested design. This is one of the simplest design we have that has been tested from long ago, and I'm talking Mercury, Gemini, Apollo. We have been testing this, and again, Russia has been using this for more than 100 launches. So it is time tested. It's like we tested this, and on top of that, Boeing has played a very crucial role in space, basically space race. So they have a lot of subsystem which they have already tested. For that reason, they had very high confidence in this design. Because space shuttle failed so spectacularly, they have to go back to basic and be like, hey, this time we have to make sure that if we send astronauts up, they must come down safely. So safety became the paramount. So they are like, let's not take risk, let's go tried, tested stuff. Now the only difference, instead of these two systems, they, instead of having the launch escape tower, they have launch pusher system. Basically, instead of pulling the capsule, it's going to be pushed. So the pushing system, now this is one big difference between SpaceX approach and Boeing approach, is Boeing have all their jazz into the service module. So if something faulty happens, let's say due to the rocket, the service module is going to push the craft away, same as SpaceX. However, SpaceX engines are embedded into the capsule itself, so capsule can do the escape system. Here the service module will do. So that's one core difference. Now the system with this way is, it has to go to space. Now it's very unlikely they're gonna launch and they're gonna dock with ISS in 8 minutes. They can reach the height, even the orbit, but because of the orbit maneuverability, it's never gonna be like, okay, here's ISS, go and dock. It always, they're gonna have 1 or 2 orbit to, in space, or sometimes it could be 1 whole day. So how the heck people gonna stay there in 1 day? They need power for that. So the power will be provided from service module. Backside of service module will have solar cell. The power output of these puppies are around 2.9 kilowatt. Now space shuttle had this big issue, because even if they did not have a solar panel, they had a fuel cell. Now the benefit of fuel cell, it works without solar panel. So they do not have the fancy things of how the heck you're gonna open it, unfold the solar cell. It had a lot of power and all that, but it had side effect in terms of longevity. Basically, if they are stuck in space, they're stuck in space where they have to return, otherwise they're gonna run out of power. Here solar cells and modern electronics are so efficient, they can survive in space for much longer. So service module will have a lot of core components here, same as SpaceX, only the escape system is not in the service module. So this is the capsule design, bit bigger than Apollo, bit smaller than Orion. So what about testing? It's one thing to, like, everybody has big dreams and desires, but you have to test the damn thing. So they started the physical testing. Basically, they physically started to build the mock-ups, physically started putting flight hardware, testing the weight and all that jazz. That started in September 2011. So you can understand, it's like it's been going on for a while. And the first big test that they did with hot, basically flight article, was done in pad abort test 4 November. It's a recent kind of thing, and it was done in 2019. Then one of the biggest launch testing they could have done is Boeing orbital flight test, which was done in 20 December 2019. Again, not very far ago. Now all of them were behind schedule. Now they were not behind schedule by, in the beginning they were like behind schedule by 3-4 months. Right now they are behind schedule by 3 to 4 years, so to say. So things are not going as well. So what does that mean for the future? Well, they did not even had a clean test. That is the biggest problem. When they had basically their pad abort test, things worked. The pusher system worked as it's supposed to. It pushed the thing out. However, the parachute failed to deploy. They had 3 parachute, all 3 supposed to be deployed, but it failed. One of them failed. That's why there is only 2 parachute. However, in the return, when they had orbital return, all 3 worked. But you have to understand, they have 2 launches and one of them had a failure. So that's a 50% failure rate. Now, thankfully, the systems are overbuilt. I told you, like, we went back to the basics, so everything is overbuilt like hell. So these 2 parachutes can safely land the capsule, and people will not even know. They will not even know it unless there is a computer telling them, hey, 1 parachute is not working. They will not even know it. So NASA is satisfied. This aspect is that, hey, if astronaut was inside it, they will survive. Like every G sensor, every testing system they had is like, yeah, it is safe. So that is one good thing. When they had basically orbital system, which SpaceX has already accomplished, basically go to ISS and dock on your own, which SpaceX already accomplished. They wanted to do that, they failed. The reason for failure is basically their clocks were misaligned. Now, is that a minor issue? Well, it happens. It's a new thing. It's not a new thing. It's happened already with Russia multiple times, and even with the American system happened. It happens. This kind of thing happens. However, the people on the ground already knew what was the fault. Once they started, hey, dude, the rocket is doing something it's not supposed to do. So why didn't they issue a correction? Again, they could have issued the correction, but their luck was so bad because satellites are rotating, and the satellite that is, like, communicating the system, basically is relaying the data, it had a blind spot, and the capsule ended up in that blind spot. So when they could have sent the data and like, dude, correct yourself, they failed to do that simply because, think of this, I'm a satellite and I have this cone. The capsule was again outside of my cone of communication, so it failed. So they could not have done that. Could astronaut have done that? Boeing says absolutely. Most likely they could have saved the launch simply because that is the whole job of an astronaut. It's like, if automated system fails, you're supposed to take care of it. So it could have been done. However, even in this scenario, when they had a field of clock misalignment and rockets overfiring, this is one critical aspect. Basically the pusher system that was there, and rear wing, it was overfiring. It's not supposed to fire for that long, and none of them had a failure. So that was a very good thing. Like, they wanted the test time frame they have. It's like, hey, you're supposed to fire for 2 hours. They pushed it to like 3 hours, and none of them blew up. So that is a very good thing. However, that clock system was a very big oops. It was not a, boom, oops. It was like, really, really, bro. So thankfully, no harm to the crew. Like NASA, both of them, NASA has double checked, triple checked everything. It's like, if people were inside, they would have come back alive. Nobody did. So everything good. However, this puts them really behind. It is very difficult for them as of now, as of me making this video, to put a mid 2020 crew launch system. It is very hard for them. Like, they have to push 24/7 into 365 to get that kind of thing done. So in 2020 is going to be a very big year for basically America, because if things go accordingly, SpaceX should in principle able to launch crew to ISS using American built rocket, using American launch pad from with American astronauts. So that is a very big deal, because you have to understand that till after the space shuttle retirement and now basically this whole point around almost a decade, they have no space capability. Basically, America had space capability and they lost it. So it is a very important year, and if it was delayed, it will become like another year for the Russian system to troll them. It's like, hey, how about we increase your ticket price, because what else you gonna do? So it's a very important year, 2020 for America. So this was my presentation on Boeing system. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your extra disappointment. Please leave a comment, because I try to reply to all of them, and subscribe, press the bell icon if you're free. And as always, thanks for watching.